Hi there. Those cookies were good, right? So I always think like when I get a big cookie like that, that's more like a sleeping pill. So I'll try to do my best to make it entertaining for you. What I want to talk to you about today is GE. Let me start with a company overview for like 30 seconds. GE is an industrial company these days. The big four for us are power generation, healthcare, oil and gas, and aviation, and that is complemented by our capital business. We have moved from being mostly capital-driven, 70% capital, 30% industrials, to now close to 75% industrials, 25% capital with the latest Alstom acquisition. So it's really all about business to business, and now that we're even selling our appliance division, we will be even less of a consumer company. But we do purchase and make about $77 billion worth of materials and processes. So manufacturing is a big deal for us. And what I'm going to talk to you today about are two major changes: additive manufacturing and what we call the Brilliant Factory. So let's start with a quick video on what's happening. Can we hear it? Yes.
Manufacturing is moving forward. It's the dawn of advanced manufacturing. It's forward thinking, forward moving. It's real progress. Ideas at work, that can be put to work. It's know-how. It's wonder. It's scale. Advanced manufacturing. Developing material science, innovating, and creating opportunities with the industrial internet. It's embracing a new way of working, a new standard of efficiencies, from top to bottom, from supply to product. Reimagining the workforce with a new, more powerful set of skills. It's a commitment to train people to make new things in a new way, so we can all work better. Advanced manufacturing is happening now. It's a reinvestment, a revitalization in industry, in jobs, in economies, an economic engine that's going to move all of us forward.
So why is it so important? You know, so for me, I work in research in upstate New York. I'm the chief scientist for manufacturing, and for a guy like me, the best thing that can ever happen is that you have a chairman that says, "I want innovation and I want to focus on advanced manufacturing." It's hard to beat that. What I want to explore with you today is why is that? Why is our chairman so focused on these two areas? And it's really the digital revolution happening in manufacturing that we have been seeing within the consumer internet, 10 years ago. Just last week I was at a conference and somebody asked me, "So why is this really revolutionary? Haven't we done all this? And isn't that all like stuff you just stick together? Is the components?" So the components have been there for a while. How do we stick them together? But really what drives this is the enormous increase in speed in data. So if you think about, I compare that to, when I had like dial-up in the late 90s, and today I have much, much faster internet. It's not like, that's an evolution. I mean, there's no real big magic happened, but it enabled business models that we could have never seen before. And I think that's really the third industrial revolution we're talking about, is that digital meets the physical, and that drives agile manufacturing and entirely new ecosystems and new business models. And I'll give you two examples of that this afternoon, and hopefully then we have some time for discussion. So it's that what we call the third industrial revolution. It's 3D printing that is changing the world. Everybody thinks it's changing the world, but right now, I think in 2012, 0.02% of all things were made additively or 3D printed. People use those two terms interchangeably. So it's a revolution that's going to come. We all really believe that it's going to come. It might be a little bit overhyped. But it does. So let's talk about the hype, and then let's bring it back to what can we do today. So anyone can be a manufacturer, So we have this maker movement, every week or every other week I'm getting an email, "Come to my maker movement," and people show you great stuff. We have like companies like Quirky and Plethora and all sorts of small startups that don't have these high barriers of entry anymore. They can be in manufacturing, which is very exciting to people. People like to make stuff. You can think of manufacturing as a service. You know, I just had a conversation during lunch, and I think you're going to talk afterwards about this. You know, how we can think of contract manufacturing and additive. You know, I have a friend who went to Indonesia, and he is an avid photographer, and you know, a part in his camera broke. And he was really devastated. And he went to a photo shop, and the guy didn't have the part, but he did have an additive machine that could print the part for him. He had to pay $150 for a little plastic part, but he could use his camera. So this is really changing the world right now on a smaller scale, but you'll see over time it will get bigger and bigger and bigger. And then the last thing I want to talk about is, you know, the industrial internet meets manufacturing. How do these data pipes really change manufacturing as a whole and make our factories what we call inter-brilliant factories, meaning how do we can connect them from design to manufacturing, engineering to operations to the supplier and back to the service and get to products that continuously improve and factories that never stop. That's the topic for today. So here are a couple examples on additive manufacturing. And really, there are two parts in it. So there's metal-based additive manufacturing, and then there's sort of like plastic, ceramics-based additive manufacturing. And GE is a leader in metal-based, and we dabble in the other part. There are certainly people in Europe who are much, much better. There are people who are setting up shop now in the U.S. But in the plastics part, in the plastics part, it's usually Europe that's right now ahead. And you see a couple pieces here that can only be made additively. You know, that's the other exciting part about additive manufacturing. They are parts you cannot make in the traditional way. You can only make them through these 3D printing devices. Lots of problems with that. You know, the quality is not what it needs to be. Material structure is not what it needs to be. It's too slow. It's too expensive. But the promise is truly revolutionary. So here you see a couple designs here. You see here fewer constraints on design. So the interesting thing here is our engineers, who have been the best engineers on subtractive manufacturing. And when we talk about subtractive manufacturing, we really think about, you know, there's a big block of metal, and then you have a mill or a grinder or some equipment that takes metal away. And in our aircraft jet engine business, sometimes we machine away about 90% of the raw stock. Think about that. We're wasting 90% of the material because we have to make a certain part. We can only make it a certain way. In additive, you waste nothing or a lot less. So sometimes, you know, there has to be some post-processing in additive, then you have to machine a little bit off. But a lot of parts you can just make in the exact shape you want them to be made. And when we talk about 3D printing, you just basically have to think about a printer that is slowly moving up and deposits material, and the part is basically being built up from the bottom. That's really how it works. Again, lots of problems there. You know, structural analysis. Our engineers are really trying to figure out, you know, are these parts safe, right? You don't want to have a part on your jet engine that doesn't meet the same criteria from the FAA. We have to work with the regulators in figuring out how do we certify these processes and so forth. But you know, lots of challenges, but you know, lots of promise. And I can tell you, in 2020, we'll have printed about 100,000 fuel nozzles for our aviation business. So 100,000 parts will be on jet engines flying. Fuel nozzles are essentially the things that put the jet fuel into the engine. And that's really exciting for us. So we're actually utilizing that technology already. I think I told you we think we are ahead of most people in this area. And as a result, we're getting much, much better fuel economy on our jet engines because we can print parts or design and manufacture parts that we wouldn't have been able to make otherwise. So is it the next assembly line? Not yet, but I think we will get there eventually. And I think, you know, people have been talking about eventually we'll be able to print an entire engine, an entire, you know, I think Boeing said they'll print it in an entire wing. That will all come, but right now we can make parts that are roughly, you know, let's say a couple feet by a couple feet by, you know, maybe 5 feet or so. What it will enable, and I think here's where people also get excited, so it's parts we could have never made, but also it will enable this local production. So think about this example I gave you from the photographer in Indonesia. You can make those parts there. For those of you who are, I think we heard a talk from GM around lunchtime. Just think about, when you stop making a car, you usually have a runoff so that you make the parts that people will demand for 10 years from you when they have an accident and they need a new fender or whatever, or a new quarter or a new door. And you don't really know what these people will demand, so the demand is uncertain. So I think the auto industry scraps about 40 or 50% of these replacement parts because they never really need them. Just think about what it would mean if we could make these additively at a competitive cost. So finally, it's the business model. It's crowdsourcing is going to be possible. So if you look at the right side there, I don't know if that's going to work. Let's see here. This thing here, I cannot see it. This here is a bracket on a jet engine. And so we just wanted to test something. We just wanted to figure out, what could we utilize crowdsourcing methods to redesign that bracket. And we thought, we put it in there, we hired a company who would host this for us. And we thought, well, maybe we get like 20, 30 people designing that bracket for us. We put a prize out there, and the best design would get a prize, I think, of $10,000 or so. Now, it turned out 689 designs is what we got. We had a hard time. The guy who judged the competition, he was not very happy about that because he had to qualify 689 designs. The guy who designed it came from Indonesia. We had never heard of the person. He had no formal education in engineering as far as we knew. And it's just amazing what that gives to you. And think about what that means for the future of innovation, for the future of engineering and manufacturing. You basically can build these ecosystems that are driven by 1,000 people, let's say, at corporate, and 1 million people on the web helping you design and innovate new processes. I thought that was amazing. And oh, by the way, what we tried to do is we tried to reduce the weight using these additive technologies. And we reduced the weight by 85%, which really matters if you put it on an aircraft engine. So additive is going to change the world, not tomorrow, but maybe the day after tomorrow. The other thing I want to talk to you about is this industrial internet meets manufacturing, because think of that ecosystem I just described to you. That's really amazing. And so now I want to think about how can we get that ecosystem in an environment of quote-unquote traditional manufacturing, which still serves like 99.9% of manufacturing. And that's what we at GE call the Brilliant Factory. I'm going to walk you through this. I know most of you guys are probably not hardcore manufacturing people, but I think what you should pay attention to is what this supply chain will enable you to do in terms of crowdsourcing, in terms of connecting with the customer, in terms of reducing customer lead times. I think you have to demand from your supply chain leaders that you want your stuff faster, you want it more customized, and you want to work with those supply chain leaders in your companies and say, how do we partner here? How do we figure this out together? If it doesn't come from you, if there's no demand from you, the supply chain guys, they will not change. Okay, it's your initiative that's going to drive people to go after faster lead times, more customizable, and maybe also cost. So when we think of manufacturing, we think of two changes in paradigm. One is Ford, the assembly plant. He essentially reduced the cost of a car more than tenfold. You could buy a Model T for about $500. Even the guy on the line could afford it. The next revolution we saw, the next paradigm shift is 1950s, 1960s, which is lean manufacturing. The Japanese essentially killed everybody who was in the auto industry, everybody who was in the camera industry. And how did they do it? Well, they basically came up with, what the MIT guys termed the machine that changed the world, which is a very cute title because it wasn't a machine at all. It was basically lean principles, how you derive waste out of your factory and do that in a very, very structured way. But the next thing we really think is, how do we get to a brilliant factory? How do we get to a factory that essentially is completely synced up with a supply chain where all the data that we're getting from a robot, a controller, IT system, maybe the demand from a customer, how do we sync up all those data and how do we basically play conductor and say, all right, how do we sync it up? How do we make sure that we are utilizing all those data to give the customer what they want and do it at the cheapest possible way? So this is the schematic I'm going to walk you through, and then after that we're going to go to questions. So it all starts with virtual product design. Every single product today is, or most products today are designed virtually through some CAD software. The auto industry has certainly been the lead on that together with Aero. Today, I think they don't even need to do crash simulations anymore. They can do that all in virtual. And all of their suppliers and all of their design is done what they call model-based engineering. Then that is going to be passed to the manufacturing engineers. So the product guys design the product in virtual. The manufacturing engineering guys have to design the factory in virtual. So they have to figure out, how do I cast, join, how do I do all the stuff I need to do to make the product, how do I make that virtually, how do I work out all the bugs before I put it on the factory floor, because that's where it gets really expensive. After that, you get to the smart factory, and now you have to think about, how do I utilize all that real-time data that's coming at me from that factory through those big data pipes now, and how do I optimize the resources in those factories and from our supply chain and make sure that I do it in the fastest, most efficient way and in a way that it benefits my customers the most. And then finally, how do I connect my supply chain network to that? Because I have to have all the parts before I start, right? If I have a car and I want to make a car with 3,000 parts, I really can't do that unless I have all 3,000. If I have 2,999, it's really not going to work out, and the car is going to get stranded somewhere. The important part in manufacturing is that things always go wrong. No matter what factory I've been at, every minute something goes wrong. And so what you want to do is you want to use that digital twin that you designed when you designed the factory to figure out, Harry doesn't come to work. This supplier is not giving me the part. This machine is breaking down. How do I make sure that I react to that disturbance in the supply chain and in the factory in the optimal way? So I'll give you an example. Let's say we have a robot cell with 5 robots. Those robots make a part. And now the data from those robots tell me in 10 minutes this thing's going to go down, right? So you all talked about analytics this morning. There's a lot of analytics going on, not only in consumer, but also in manufacturing. So we can utilize the data that comes from those robots and say, this is probably going to shut down in 10 minutes from now. What are we going to do? So what you want to do is you want to reconfigure that robot cell, and now instead of 5 robots doing the work, 4 robots do the work, slows down a little bit, but the factory still works, and you get to a factory that effectively never stops. The second piece is this design feedback loop, where you could look at, most GE products, jet engines, turbines, and so forth. They're all serviced. Our customers send us these products back. We service them and we give them back to our customers so that they can continue to use them. And every time you open up a jet engine or a turbine or a healthcare product, you can look at that and you can see, what went wrong? What parts broke? What parts were used more? And now you have an opportunity to give those information back to engineering in a structured way and say, hey, this particular gear, I'm always missing a tooth here. This is the part that always gets worn out. Why don't you redesign that? So you get continuously improving products, even in very long cycle businesses where people use these jet engines for like 20, 30 years. So it's that structure that we think forms the 21st century brilliant factory. And now you can say, but all these parts, I've seen that before. It's the data pipe. It's going from dial-up to glass fiber, fiberglass, that enables you to do things now you could have never done before. It enables you to do technology and analytics that you could have never done before. It enables you to connect to your customers and to your suppliers you could have never done before. It's a changing business model in the ecosystem where you can now integrate and unleash the power of innovation from all those small and medium enterprises that before could never really contribute to a large company like GE in that innovative way. It's those changes in the business model that make it brilliant, and the connectivity that will allow us to be faster for our customers, to be cheaper, and to fulfill better, and to create that ecosystem that will undoubtedly, in my mind, change 21st century manufacturing. So our first example we have in Schenectady, we have a battery plant. We put like 10,000 sensors in there. We can now figure out basically from the powder, how we make the cells, to the end battery, what went wrong with the battery if the battery fails. Maybe there was too much humidity while we are pressing that particular cell. It's 10,000 data points every 250 milliseconds, and our quality engineers mine those data, and it helps them to improve the product much, much faster than we ever could before. So here's the vision, creating that digital thread, interconnected, automated, never surprised, factories that never stop, products that always improve, and an ecosystem that is analogous to our additive. That's why I want to stop, and maybe we can have a little chat if we have still time. Yes?
How do you explain the design problems at GM with their ignition switch?
Yeah.
Mr. Talk earlier.
So, well, great question. So, thank you. Once you get that digital thread that I designed, you get for free what I'll call product genealogy. So I can really look at every single car, who assembled the car, what suppliers' parts went in there, what shift was it assembled on. You basically get, just like we had this example in the battery, a perfect product genealogy for that car. I used to work for General Motors for a long time. And I'm convinced, I think they recalled about 2.6 million cars based on that ignition switch. I'm convinced they could have probably recalled something like 10,000 cars if they had known exactly what ignition switches were faulty, if they had that perfect product genealogy. I have no proof of that. But what you do typically is you have to cast a much broader quality net than you want, because you don't really know where the faulty parts are.
But my question is about that virtual design process.
Yes. Oh, where did it fail? Right. So the question, I think, is how come that there was no simulation that tested when somebody put in, I think the problem is, and again, I have no affiliation with GM anymore, I don't know what the problem really is, but I think the problem is that the keychain is too heavy, and that causes the key to go back. They just didn't think about that failure mode, right? When they tested that in their simulations, if they had a simulation for that, which I also don't know, but if they did, they didn't test for that particular failure mode. I think it's very, very difficult to think of all the failure modes, especially as cars are going more and more, depending more and more on software. I think you have like 10 million or so lines of code going into every car these days, and close to 100 computers. Things will go wrong. It's a question of how you manage what you do when they go wrong. Yes?
Thanks. Hi, Hi, Rachel Feddersen from The Week and Mental Floss. So I'm in media.
Yes.
And we also have a flood of data available to us now. And
Yes.
I'm curious, one challenge that we have is that we have this flood of data, and it is a lot sexier to talk about data than it is to talk about the personnel that you need to make sense of this data. And
Yes.
I'm wondering if there are analogies in your world
Yes. Yes.
and how you've grappled with them.
Yes. So we recognize that problem, and so it's those data scientists that essentially turn the data into information. You know, there's this adage that basically says we're drowning in data and we're starved for information, right? And I think that is true in your business, as you said. It's true in manufacturing. I think it's true virtually everywhere. So we have like lots and lots of data neatly stored in databases, and nobody ever looks at it. You know, the best thing you can hope for is that, you know, when a machine breaks down, the maintenance person who goes to the machine, maybe they look at the last half hour of, well, let me see what happened in the last half hour. Maybe there's some error messages that help me decipher what I have to fix. What we want to do is, I think what you also want to do is we want to have automated analytics that allow us to figure out for every factory where's the bottleneck, meaning like what is the machine that gates the output of the factory, what part are we not getting. We want to have automatic analytics as opposed to data. And so GE has actually started a software center out in California, in San Ramon, about three years ago or so, where we have hired about 1,000 people that help us develop those algorithms. We also have researchers in our upstate New York facilities working on that. And so we're working on two parts. So the people out in San Ramon mostly work on improving the assets of our customers. So if we get, I don't know, terabytes of data from our jet engines, how can we figure out whether we need to service that jet engine earlier or later? How can we use those data to figure out what to fix once the jet engine comes in? In a wind park, how should we turn the rotor shafts so that they take the optimal advantage of the wind? How do we use control that enables us, together with analytics, that enables us to make the assets of our customers to perform better? What we are focusing on in the Brilliant, and we call that the industrial internet. What we focus on in the Brilliant Factory is that same concept where we say, oh, okay, so here's our own factories, our own assets, and how do we use the data better that we get the most out of our factories, that we improve the performance of our assets in that factory. Now, there's no magic in this, right? So you have to think about how do we get this into the hand of operators, line supervisors, plant managers to make their life better. And just like you are in media asking, I'm getting all those data, but I don't really know what to look at. I don't really know how to analyze it. If I do an analysis, it takes 3 weeks, and that's old news, right? So how do I get to an automated system that allows me to take advantage of the analytics, and I get delivered a report to myself that says, oh, okay, these are the 5 things I need to know in the next hour. That's why I want to be in factories, that's why I want to be in the service shop, and I'm sure that's why you want to be in media. Or maybe for you it's 10 minutes, but you're always a little faster. Yes, what else? Please wrap up. Well, you were great. Thank you very much. And thank you.